Okay, in this video, we are going to jump a little bit. So I know it's in the connective tissue section, but this is not actually connective tissue. So we're going to talk about joints. And joints are made up of connective tissue, but they themselves are not connective tissue. But I think it's really important so we can put the pieces together. So a joint is a point where the bones make contact. So I'm going to share my screen again, and we'll just take a look here. So again, point where bones make contact. They're not connective tissue, but they're made up of lots of different connective tissue. And the joint allows for movement. So if we didn't have joints in the body, we wouldn't be able to move. We would just sort of be these stiff skeletons that would have to, like, I don't even think we could actually move our lower legs. It would be very, very hard to sort of ambulate around in the world if we didn't have functional joints. Now, joints are a combination of our bones, our cartilage, our ligaments, and the tendons. And they all sort of come together, and there's some additional pieces we're going to look at, but they are the reason that muscles are allowed to work. So muscles work via tendons over the joints, which are restrained by ligaments. And like we said, bones don't move, but the joints where the bones join move with the assistance of our skeletal muscle. And this is a really important concept. So joints can either help to create stability or create mobility. So there are places in our body where we actually want to have more stability versus more mobility. So we'll take a peek here. I gotta flip over to this one. And I want to just kind of look at this really nice graph. Make it a little bit bigger. So this is a spectrum of mobile to stable joints. And when we talk about stability, we want to have stability where joints meet, where we don't really want a lot of movement happening. So the most important place where that is in the skull. So, or in the cranium here, where we have bones of the head that come together, and where they meet are what we call sutures. Those are the joints. They're called sutures. And we'll look at that when we look at the axial skeleton. And then we kind of run through this graph here from most stable to least stable or most mobile. So the next place we actually really do want a lot of stability is in our spine. So in the intervertebral joints, so the joints between each one of the vertebrae, we want that to be nice and stable. So the way that the body has sort of packaged it together is it's created this really cohesive combination of cartilage and ligaments and tendons to sort of infuse and go around and create stability through the spine. And then we can go through and look at the other major joints of the body, right? So the elbow, we have some more movement there, but we don't want a ton, but we still want mobility. And then we also need a lot of mobility in our hips, and most of the mobility that we need is in our shoulders because we do most of our movement in life with our upper extremities. And then this is a really nice, I'm gonna just come back down really quick. Picture here that sort of gives this overall concept of stable versus mobile joints. And we'll take a quick peek at that too. You don't really have to remember them, but it can help to know a little bit more about it. So on the right side of the body are the things that we consider mobile. So our ankle is very mobile. We have hip mobility. We want our wrist to be able to move. Our thoracic spine actually has a lot of mobility in it, and that's important for rotational movement for us. And then our glenohumeral, our shoulder joint. And then where things are more stable, so elbow was kind of right in the middle, remember, on that space. So it had movement, but it didn't have a ton of movement. And then, sorry, it's not even movement, it's stability. So the other places we want our joints to be really stable in the cervical spine, where our scapula and our thorax meet, and our lumbar spine and our knee. Now, we have mobility, we have the ability to move in those joints, but we don't want a ton of laxity, which means a ton of movement. Because if our cervical spine wasn't stable, if it wasn't supported, our head would just sort of fall to forward or fall to the side. But so, whoop, well, hang on one second. We got to get the screen share to work again. So there are different types of joints. And the one that we're going to be most focused on is one called the synovial joint. I think that's the most important one for us to look at. So the synovial joint is something that we call a diarthrosis or freely mobile. So there's a lot of ability for the joint to move and to move in different directions. And the synovial joint is considered the main functional joint of the body. And that's important because we have a lot of them. The synovial joint is characterized what we call the joint cavity. So I'm going to pop back over here and come on down to our picture and click this, make it bigger for you guys so you can see. So you'll see here, this is a cross section of a synovial joint. This outer layer is called the articular capsule. So the joint, the outer portion of the joint capsule is made up of that articular or hyaline cartilage that we talked about. Remember, the cartilage that covers the ends of the bones. So you can see here we'll just pretend that this is the femur and then this is the tibia. So we'll say this is the knee joint. So there's this outer articular capsule that encases the entire joint. And then inside of the joint, there is something called the synovial membrane. So here, this orange color here, the synovial membrane. And the synovial membrane comes together with the articular cartilage. I'm losing the word, what it means when they come together. So they sort of just join together. The articular cartilage that covers the bottom of the femur here and the top of the tibia joins with the synovial membrane. And what the synovial membrane does is the synovial membrane secretes synovial fluid. And the fluid in here, it's not a ton of fluid, but it's enough fluid to create this really nice joint space that allows for fluid motion, right? So there's some fluid that sits in between that articular cartilage, and it's a little bit exaggerated here in this picture for illustration purposes. But we want to have those joints to be able to freely glide, and having a little bit of fluid in that helps that articular cartilage go across each other like this. And so we will pop into our anatomy app here where we'll look at the articular capsule of the knee joint. So this is that outer layer that we just looked at. So you can see here, so we've already looked at this knee joint, right? So we've seen the inside. So we'll, one second, here we go. So remember, here's the femur, here's the articular cartilage on the bottom of the femur and the articular cartilage on the top of the tibia. Here's our anterior cruciate ligament. Here is our meniscus, and then here's the medial collateral ligament. And then surrounding this is this articular capsule. So the synovial, the articular capsule, which helps to make this whole joint a synovial joint. So it encases it and then encloses it. And then down in here and in between is where that little bit of fluid sits, because on the inside of this articular capsule is the synovial membrane, which helps to secrete that synovial fluid. So we'll sort of zoom out a little bit here. And you can see as I rotate around that the entire knee is covered in this capsule. So the ligaments, right, of the outer, the MCL and the LCL help to create stability. Then you have this articular capsule that creates the synovial joint. So there's a little fluid inside that comes from the synovial membrane that the synovial membrane becomes, it is in conjunction with the articular cartilage. And that is what gives us the ability to move our joints very freely and with ease and without a lot of pain. Let's see, we'll go back to our section here. And there's a couple different joints, synovial joints, depending on how they move. You don't really need to know that, but you might want to know that the knee and the elbow are hinge joints, and that the hip joint is a ball and socket joint, as well as the shoulder joint. And you'll see that when we look at the bones. And then the other types of joints are cartilaginous joints and fibrous joints. So an example of a cartilaginous joint is the pubic symphysis, which is the little bit of, it's a joint that connects the two hip bones together. We'll see that later. And then also fibrous is the type of joints that are in the skull. So the really important thing about joints that I want us to just take a minute to look at here, and we'll make this bigger for you guys here, is that there are natural consequences to range of motion in joints for a variety of different reasons. And this is really important as a yoga instructor to recognize this early on when you begin teaching. So everybody is, and majority of people's bones are very similar, but you have to understand that some people's joints, with the way that their bones meet, don't actually move the same as others. So when we're talking about a joint, there can be some major constraints to actual joint movement, and that's important when we're looking at alignment in our students. So the first really important concept is this idea of bony compression. So the bones, when the bones bump together, even though there's that joint, they have that, if it's a synovial joint or whatnot, when there might be a little bit of space there, but when they come to the point when the angle, they can't go anymore, then they just can't move anymore. And a really common place to see bony compression is in somebody's ankles. So people will have different makeup of the bones so the fibia and the tibia that connect to the calcaneus, the heel bone. And when they go to flex the foot or point the foot, they may not be able to do it as much as somebody else. And one of the places that you can see that a lot is in downward facing dog. So some people have the ability to put their heels on the ground and some people cannot. And sometimes that's a result of bony compression. The other thing that can be a result of too is ligamentous. So as a joint nears its end range, the ligaments become really taut and they resist movement. So some people have a little bit more laxity in their ligaments, and not a lot, but there is this range of people being able to move the ligaments. And so there's a big ligament that runs at the back of the heel. We call it the Achilles, or it's a tendon, actually, Achilles tendon, but there's also some ligaments that are back there. So as people move their ankle, it can be one of the limiting reasons why people can't put their heel down onto the floor. The next is muscular. So when we talk about muscular constraint, what we're talking about is that muscles can sometimes generate some passive tension. And when they generate this passive tension, it's really hard to be able to go beyond that point of passive tension. So you get to the point and the muscle just kind of stops there. And you may need to create some more stretch before you can go any further. So the muscle can limit the range of motion of the joint itself. And then the fourth thing that can constrain the movement of a joint or how much the joint has range of motion is soft tissue compression or body habitus. So the most common, the easiest one to think about this is when we talk about a forward fold. People that have a larger body habitus, when they fold forward, the abdomen, because of that soft tissue there, as they come forward onto their thighs, they may not be able to have as much range of motion in the spine when they do forward flexion because the body stops, the soft tissue stops them from being able to go forward. So we want to get out of this concept that there's this ideal look to any particular an ideal for any asana, right? Like we need to really be conscientious that everybody's body's different. Everybody's bones are different, their joints are different, their muscles are different. They have different laxity in the ligaments, they have different abilities to stretch the muscles and the tendons associated with the muscles. So, although there is a certain shape that is familiar to each particular pose, there is no true ideal. And we need to be really conscientious about that when we look at our students. And joint constraints can really create some different looks in different people. And it's something to be really aware of as you begin teaching, because we'd like for you at Cambio to not um, be creating or forcing anybody into a position that's not correct for their body. Each of us is our own best teacher, and we can sense inside of ourselves where our limitations are in terms of our ranges of motion. So it's important to honor that. And then I've added a fifth one. It's not necessarily one of the major constraints, but it can stop people. So pain, stiffness, or soreness, right? So pain can be stiffness or soreness. And the place I said we talk about this later. So remember when we talked about bone on bone. So when the cartilage can wear out in people's across the when cartilage wears out, what will happen is it degenerates and the bone will start to touch bone on bone. And when you go to move bone on bone, it can be really painful for folks to have bone on bone touch. So we just want to be conscientious that if there's pain or stiffness or soreness, we want them to be aware, right? Like just have a general awareness of what their body's doing. And I think that's it for now. So we'll see you in the next video where we'll cover fascia.